Stoichiometry is the use of a balanced chemical equation to determine the amounts of chemicals needed or produced in a chemical reaction. In this chapter, amounts will be expressed as mass, which is the most common since this is the most practical, moles, or number of particles. A stoichiometry problem will always give an amount of one chemical and ask for the amount of a different chemical. These two chemicals are related through a balanced chemical equation. We will consider the coefficients of balanced chemical equations to represent moles rather than molecules or formula units. For example, the balanced chemical equation on this slide, which reads coefficient of 3, capital H subscript 2, or hydrogen, plus coefficient of 1, capital N subscript 2, or nitrogen, arrow or yields coefficient of 2, capital N, capital H subscript 3, or ammonia. We would read this as 3 moles of hydrogen react with 1 mole of nitrogen to form 2 moles of ammonia. The way that we use the coefficients in stoichiometry problems is through a mole ratio. A mole ratio is the ratio of any two chemicals in a balanced chemical equation and their respective coefficients as moles. For example, here are 3 mole ratios from the balanced chemical equation we just considered. 3 moles of hydrogen to 1 mole of nitrogen, 3 moles of hydrogen to 2 moles of ammonia, and 1 mole of nitrogen to 2 moles of ammonia. What are the other 3 mole ratios for this balanced chemical equation? Pause the video to write them. Here are the other 3 mole ratios in no particular order. 1 mole of nitrogen to 3 moles of hydrogen, 2 moles of ammonia to 3 moles of hydrogen, and 2 moles of ammonia to 1 mole of nitrogen. It is really important to include the word mole in mole ratios. You will need the word mole to cancel out units correctly. A mole ratio is required in every single stoichiometry problem. The chemical you want to end up with will always be in the numerator or the top, while the given chemical is always in the denominator.